Christoph, and good morning everybody from the UK. So I'd like to introduce you to Inivos. We're the specialists in automated decontamination, infection prevention control. And I've got my colleague here, Tom Lister. Tom's our head of client development, and I'm responsible for global business development. And we'd like to just run you through our technologies and what we can offer for superior infection prevention control solutions for healthcare. Tom, please take the floor.
Thank you, Rod. It's not letting me share my screen at the moment. Is there something? It's saying another participant is sharing.
Sorry, there shouldn't be a problem since I don't see anyone else sharing. Just let me check.
Maybe try now. Maybe try now.
Okay, sure. Thank you.
Coming out.
Very good. Okay, you should see my screen now. Is that working for you? Good, thank you. So, yes, good morning all, and thank you, Rod, for the introduction. I wanted to quickly give you a brief overview of who Inivos are as a business, and then a quick fly through of some of our core technologies and how we're working in the global markets. So we are a specialist. Essentially, our roots are as a medtech development company, and we're very focused on enabling healthcare environments to deliver better care faster. So better patient outcomes, reduced cost of care, reduced infections as a result of implementing our technology. Established in 2007, and we do have a strong market share in the UK. We're privileged to work with nearly half of the NHS acute hospitals, and we've got a number of product development and technologies going on in the background. We do have a global presence with our own offices in a number of regions around the world, but we're also actively looking for distributors in Europe, Middle East, North Africa regions. So hopefully there's some synergies with other companies on the call today. A very brief overview. So our speciality is in automated decontamination, but we recognize the fact that infections in hospitals are transmitted through multiple vectors, primarily surfaces, water, air, and people. And so we are developing technologies for all of those four vectors. Very briefly, our core technologies for the automated decontamination sector are primarily hydrogen peroxide vapor, then a mobile UVC decontamination, and then our latest technology is actually a fixed UVC decontamination where we can essentially retrofit a technology so we have a self-decontaminating space. And then ProxPod is something that was kind of born out of COVID, which we can talk through further. So I'm conscious of the time, so I'm going to keep things very brief. But essentially, the hydrogen peroxide vapor system is the fastest, high efficacy, single unit decontamination technology available anywhere in the globe. So when we're looking at high-end decontamination with hydrogen peroxide vapor, traditionally it's a 4 to 6 hour process because we're introducing a lot of hydrogen peroxide vapor into the room, and we've got to then deactivate it. We've been able to engineer it to a less than 2 hour decontamination process, which obviously for hospitals, turning rooms around faster is a very significant driver. Consistent validated efficacy is a really important part of automated decontamination. And there are many technologies out there, and especially as COVID has come about, we've seen the market kind of flooded with these cheap fogging machines and all sorts of spraying devices, from a fence paint sprayer to any kind of an aerosolization device. All of a sudden gets paired up with some kind of a disinfectant, and hey presto, we've got a decontamination system. The reality is it's very important to be able to validate a redecontamination process, and as long as that relies on the operator, it's essentially still a manual process and open to a number of environmental variables. One of the patents is secured on with our technology is how it actually monitors the environment in real time to deliver a calibrated decontamination dose for every decontamination cycle. So it's a little bit like a kind of a desktop sterilizer in a sterile services department turned inside out. So we're kind of doing that same process to the environment. But what the benefit for the client is that it actually, because it's monitoring the environmental variables for every decontamination process, we're able to ensure a repetition of every cycle, so that it's actually it is a repetition of what was achieved in the laboratory environment when it was first validated. And so for every decontamination process, it generates a report which is saved to the cloud and it sends to the customer as a PDF with a validation of every decontamination cycle. So essentially, we're achieving at least the log 6 efficacy of C. diff and bacillus spores, which are used as kind of an indicator organism as some of the hardest organisms that we come across in the hospital environment, but also very strong data against other bacteria and viruses. So like I mentioned earlier, we've had the privilege of working with well over 130 hospitals to implement this technology now. And what we're proud of is that many of them have gone on to publish studies, some of them peer-reviewed and in the journals, where they've reduced infections by 50 to 60% as a result of how they've implemented our technologies. So certainly would welcome any further questions on that, and conscious we're having to go through very briefly in the time available. UVC decontamination is something that has become much more popular in the last 9 to 12 months. It was something that was first introduced in America about 6 years ago. We introduced it in the UK about 4 years ago, and working with a significant number of hospitals with the technology. The beauty of UVC is decontamination is so much more rapid than technology like hydrogen peroxide vapor. So typically we can decontaminate a room in about 25 to 30 minutes, which again, you've got that turnaround time benefit. The real challenge with UV, however, is that to decontaminate surfaces, it relies on surfaces being exposed to a sufficient intensity of the UVC. So essentially a dose. So you need intensity over a cumulative time period. And there are a number of factors that affect the intensity that we're able to achieve around the hospital environment. So primarily you've got shadows. So in any room that you go into, there will be surfaces that are in shadow from the UVC system, for example, under the bed and behind the locker. Also, as distance increases from the source of the UV, the intensity diminishes on the inverse square. So given the fact that every surface will be a different distance from the UVC system when you set it up in the room, every surface is actually receiving a different level of intensity. So the issue we have is essentially we can't rely on an operator's guesswork to simply position it in the room and hope for the best, because there's no way of validating that. What we've done, so the other solution out there, if you like, is kind of a color changing indicator paper that you can put this paper on surfaces around the room and it changes color with the presence of UV. The problem with that is it will change color with the presence of UV of any wavelength, and what we particularly need is UVC. It also doesn't necessarily give an accurate indication of cumulative intensity of exposure. It's more the fact that it has been exposed to the UVC or to UV. So what we've done differently, and again, where our kind of intellectual property is on this, is we've developed a monitoring technology whereby inside the unit we've got some electronic monitors, which during the decontamination process we position around the room. And what they do in real time is they actually monitor the cumulative exposure to the UVC, i.e. the dose. And then outside of the room, we've got this remote control. And on this touch screen here, we can see what dose we're achieving at each of the monitoring points around the room. So what that's enabled us to do is move away from having a very operator dependent process and a lot of guesswork going on and not really knowing what we're achieving, to actually being able to measure in real time the actual dose of UVC at each point around the room. And what that means is, again, it generates a report for every decontamination process, which it saves to the cloud and emails the client for their audit trail purposes. Now, a technology that we're very excited about, and we're working with a number of UK hospitals and other hospitals around the globe, Canada, Australia, New Zealand, to implement is a fitted decontamination system, which essentially turns any space into a self-decontaminating environment. So the big challenge that we were having is in high throughput areas like ED, intensive care, high dependency unit, etc., especially with COVID, was that the time component in waiting for an operator to go and fetch the machine that might have been in use somewhere else, bring it down to ED, set it up in that room. In that time frame, you know, the next patient had already been through that room in ED. So we were working with a number of clinicians, medical directors, chief nurses, and they said, look, what we really need is a self-decontaminating space. So the clinician can exit the room and the patient can exit the room. You can press a button and that room gets decontaminated in just a few minutes. So we were able to leverage the technology that we already had with the UVC to achieve exactly that. So these images are not to scale, but this is a UV system which is actually mounted on the ceiling. This is an operator interface which is mounted on the wall outside of the room. And essentially what we do is, let's say, for example, you've got a whole ED department, or it might be a theatre suite, or any area in a hematology ward where we just really want to be able to decontaminate more frequently. We would actually map that area out with a computer-aided design. We would model that room to figure out the optimal positioning of the system and how long it needs to be active for. We would then actually install that with kind of preconditioning and a with a setup and a programming, so that is optimized to that specific space. So quite literally now, a patient can exit a room, and that room can be decontaminated in just a few minutes with a fully calibrated decontamination process. So as you're all probably aware, we've got a big program, a government-backed program in the UK of building 40 new hospitals over the next 10 years. This is being specified into those new hospitals so that we actually have self-decontaminating environments. We're working on some very exciting projects with in other parts of the globe with kind of refurbishments, etc. But it is designed as a retrofit technology, so it can be implemented in any existing hospital space. It's worth also noting that an area, for example, like a theatre, you've got your main theatre and then you've got all your peripheral rooms, the scrub rooms, etc. To decontaminate those environments is quite labour intensive and a lot of complex setup, and it would typically take, or would often take, you know, an hour or two just to decontaminate it because of the space involved. What we can do with the Ultra V Connect is we actually position or install multiple units in that area, all activated from the same interface, so that within just a few minutes we can decontaminate the whole of ED. And then lastly, I just wanted to give you a bit of a flavour of our current or a current project that we're working on. So as you'd all be aware, one of the current challenges for hospitals is how they actually segregate individual hospital spaces. But then especially when it comes to decontamination, it's quite a challenge. So for example, if you've got a 6-bedded bay area and a patient becomes symptomatic in that bay, you can isolate that patient or segregate that patient, but you can only decontaminate that bay area if you can move all of the 5 other patients. What this system will enable us to do is have a rapidly deployable screening system around a single bed space, so that we can decontaminate that bed space in isolation whilst the rest of the bay continues with normal patient activity. So obviously the implication on patient flow is huge, and patient quality of care is significant. So yeah, chief operating officers, chief nurses, etc. are all over this. So that's a bit of a fly through. As you can see, we're working with a number of prestigious clients around the globe already, but we've got a strong appetite to partner to develop these technologies implementation of these technologies further, and we have what we feel is a very strong offering for the global market. So that's a quick fly through, and would certainly welcome any questions.
Okay, thank you, Tom, for a fascinating presentation and for introducing us such fascinating technology. So now the floor is yours for our viewers to ask questions. I have some, but I first let our audience to ask.
Thank you, Tom and Rob. So tell us, what's your current situation with the COVID? You must be absolutely flooded with demand from the market. What's the situation on the market now?
Yeah, that's a really interesting question. So yes, there is a lot of demand generated by COVID. I think what we've seen a lot of, though, is clients that we were already in conversation with because they had other organisms that were a challenge, and then the fact that COVID has helped focus everybody's attention on the need for infection prevention. That helped people get the funding for it. So it's probably accelerated some orders that we had in the pipeline. But then, yeah, a number of clients have implemented our technologies in order to be able to better decontaminate environments and protect patients from COVID.
Thank you.
All right, just to a little update, we have 5 minutes left, so let's shoot at the questions.
Excuse me, Tom, if I may. I watched your website and I've seen your UVC in operation, and I know you have to put the remote decoders, like as you mentioned, in the room. My question is, any damages? You mentioned paperwork, like in an office environment or in a hospital environment where a lot of documents are stored. Do you need to clear that up all the time to do this treatment for the room?
Okay, that's a really good question. So you're asking, does it cause any damage in the hospital?
Exactly.
Yeah, good question. So as we all know, UV can cause brittling of plastics and loss of pigmentation. So if you leave something out in the patio throughout a hot summer, that's the risk there that we've got to bear in mind. However, when we're operating in the hospital environment, what we've got to look at is the balance of risks. So what we're delivering here is a calibrated dose of UVC. We're looking at a very short time exposure rather than a prolonged exposure, which is where you start causing damage. Many, if not most, products that are manufactured for the hospital environment now will have UV stabilizers in them, so it's something that can easily be injected into plastics, etc., in the manufacturing process. So there are things that manufacturers are doing to actually make their products more suited to the hospital environment, given that this is now a very common method of decontamination. And then the third point that I would say is, when you weigh this up against the use of chemicals on surfaces, which is done several times a day, UVC on surfaces, typically speaking, is much friendlier on surfaces than many of the hospital disinfectants and detergents that are applied to surfaces, and surfaces are kept wet with these chemicals several times a day. So that's kind of a bit of a background. What I can tell you anecdotally is our technology has been used for well over 4 years in getting on 100 hospitals, and we've never had any issues with compatibility. We also have our own laboratories where we carry out highly accelerated life cycle testing, where we get components and materials and products that are used in the hospital environment, and we expose them to repeated UVC processes to test for any damages. And we do the same with the hydrogen peroxide vapor, and again, to date, no compatibility issues.
Okay, we have time for one more last question.
Yes, hi Tom. Are there any consumables associated, or is the extra cost simply energy in this product? Number one. And number two, do the clients in your experience, prefer to purchase the product or a service?
Good question. So number one, no, there's no consumables apart from we put a warning sign on the door, and if there's a big gap, if there's a visible gap around the door, we tape it up with UVC impenetrable tape as a safety measure. But there's no chemicals, no consumables. Whether they prefer to purchase it as a technology or a service seems to differ from country to country. Predominantly in the UK, though, our clients have purchased their own systems or leased their own systems and operate it themselves. And we've had a heavy focus on the product development to make sure that it is suitable for general cleaning staff to operate. So it's very intuitive, very easy to use technology. The user interface is mainly pictures and diagrams and animations, so that language barriers and ability to read is not a problem. So essentially it comes down to what's best for the client. But there's a business opportunity for both.
And do you offer your partners all sorts of financing options? Is it simply you sell the product? Do you offer leasing options, financing options, depending on the client's needs?
Yeah, depending on the client's needs, all of the above. So typically we sell them, but we do work with third-party financing companies to make them available via lease as well.
Okay. Thank you.
I will just very, very briefly, wasn't sure how the time would pan out, so I'm just going to very briefly show some data that shows where the need for this arises in the hospital environment. So this is an example of an acute hospital where they sampled environments before any cleaning took place, after their existing cleaning process, and then after the Ultra V. So this is where patients were being discharged and they knew that they had an infection, and the cleaners knew that the room was being swabbed to test out how effective their cleaning was. And you can see that it was reduced by about 40%. After the UV, almost 100% of the contamination had been reduced. Then further of interest, this is before cleaning, after cleaning, and after decontamination. You can see on 3 sites, under the bed, the window ledge, and on the toilet roll holder, they actually found more contamination after cleaning than before. And so what was essentially happening was the cloths and the cleaning materials were getting contaminated from the dirtier surfaces, and that contamination was being spread around the room. And so typically this is what we show our clients first, and we might even do an evaluation with them in their own local hospital to actually demonstrate to them the issue that manual cleaning is subject to so many different variables, so many human factors, and essentially the net result is.
Sorry, Tom, sorry to cut you off. Just we have 2 minutes left before another page, so maybe we can record the question. So thank you again for the fascinating presentation. And once again, guys, if you want to connect with Tom or Rod, chat us in the chat message and send us your email, and we will make the connection happen. Thank you again, guys, for the presentation.
Thank you.
Thank you.
Thanks a lot, gentlemen.